So let's start with this concept of what is engineering. We're going to go over the major progression from the idea of tinkering to designing. We're going to talk about the branches of engineering, the main four that started. Now there are so many more, obviously, some more specific branches. We're going to talk about historical significance of those prominent figures, meaning the people that were really in play. Some accomplishments and marvels, and then some catastrophes. So let's start off first with the concept here. So at the beginning of this, the idea, ingenium, had to do with a person, meaning that they can devise or come up with something. That's where contrive or devise is. So it's like a person that, as a kid, you think about like an engineer, is somebody who's creative, a person who can come up with maybe a new solution to a problem that hasn't been thought out before. And if there was something that I learned in engineering school, it was how to solve problems. So it's rare that I come across something that I'm like, you know what, I'm just going to give up on this. I'm a type of person now, after having studied engineering and worked as an engineer in college, not in real life yet, or ever, honestly. But I've always thought about the fact that like there's never no solution to a problem. Whereas a lot of people see things as, oh, this becomes difficult, and it's only one way to do it, and it's a really difficult way to do it. Finding shortcuts is kind of the thing that I like to do with different things. Optimizing my time, saving time for things. And that's kind of what you're thinking about with contriving and devising different things. So these are the ways that you think about it. As a kid, you're like the kid who's that person who's always tinkering, building stuff. As a student, somebody who traditionally likes to create, likes the idea of science and new ideas. And then as a professional, obviously, a person who betters the world with new ideas. And I really try to push that in this course because especially today's day and age, like you guys heard about that terrible guy who bought the patent for a cancer drug last year. What was his name? Did you guys hear about this?
Oh, yeah. Martin Shkreli.
Yeah. He bought the patent for this cancer treatment, this drug that helps people with cancer, and jacked up the price at 500%.
Oh, yeah, and same thing with EpiPens.
EpiPens, that's the big one now.
Yeah.
Who has an EpiPen here? Anybody? Okay, so you know the issue that's going on right now?
Yeah.
It's the delivery mechanism. It's not the actual adrenaline, the epinephrine. The epinephrine costs $1. That's all it costs. The actual stuff that could save a person's life only costs $1. Now, the delivery mechanism used to cost about $110. It's now $650. Over the last 3 or 4 years, it has gone up so much money. Now, that's why I emphasize this idea of bettering humanity. Clearly, the creators of EpiPen are a bunch of scumbags, and they don't care about the fact, seriously, and they don't care about the fact that and it's mainly kids that are suffering. It's not even really adults. It's adolescents, because a lot of people grow out of these allergies as they get older. And a lot of those adults, they don't even honestly, they know better for the most part. Kids are in the lunchroom, suddenly there's peanut in their food. They didn't know, they're going to anaphylactic shock, and now they don't have an EpiPen to save their life because it's too expensive. And especially, who's it really hurting? People that don't have a lot of money. Anyone that comes from a low-income family, a lot of people in low-income statuses, they don't have good insurance either. So not only do they not have the money to pay for it, but their insurance isn't covering it either. So there are a lot of people now that are going through life that would always carry around these EpiPens in school that don't have them anymore. It's a huge problem. And you know what? Who are the people that can fix that problem? Engineers. Because it's a delivery mechanism. That's the only thing you're buying. You're not buying the actual epinephrine itself. You're not buying the chemical. You're buying the delivery mechanism, the actual device that all you do is this. Yet it costs $650 for that. Okay, it's a device that keeps the tip of the needle inside until a certain amount of pressure is applied at the end, and the needle comes out of it. You pop the end of it off. I've been trained in how to use them with our CPR classes that we have at school. So I know all. Yeah, she's really nice. She's an interesting lady, right? She's nice. You don't think she's nice? Oh, gotcha. I didn't know the person who trained us here. Well, a lot of students met her for sports. That's why I thought you liked that. But yeah, the training for it, the training for it is interesting. The training for CPR in general is very interesting. But this was part of the course now, delivering EpiPens, because of the rise of all these different allergic reactions now. A lot of kids that have peanut allergies, pine nut, tree allergies. There's so many different ones now. That's a lot of the argument. The real evidence hasn't really been proven yet, but I believe in that too. That kids are not exposed to these things as younger kids. They're not really outside enough. They're not getting those natural immunizations that the body build up over time from exposure of like being outdoors or being involved in different scenarios. I had a hiccup, sorry. All right, let's go to the next slide. So these are some simple definitions, and I'm not going to ask you to memorize these, but obviously you're going to see that there's something in common amongst all these definitions or all these, and they're quotes, because these are different engineers or different people that describe what they felt engineering is. And what do you notice is in common of all these? Application. Okay, application. One other word, design. Both are in there. And if you think about engineering is exactly that. If you ever wonder to yourself, when am I going to use math? When am I going to use the science I learned? That's what engineering is all about. It's all about applying science and math every day. Okay? So you see application, and you also see design. And you see design, I talked about design last class. I talked about how the design process is involved in everything that is built, everything that is manufactured, everything that is contrived. How about this one? Last night I ordered food. I never order food. I always cook. When I got home, honestly it was late. I didn't feel like making food. And I got an email yesterday from Uber Eats. You know what Uber Eats is now?
On the bikes.
Okay. Yeah, these guys come around on bikes, and it's through Uber. It's a delivery service. They charge you $3 for the delivery. But the email I got last night was $20 off your first order. It's like, oh, sweet, you know. I ordered $23 worth of food. It cost me $3. I gave the guy in the delivery like $3 tip. But the concept there, and I knew where that was going, right? The design of this actual service. So the design process does not actually just mean products. Services also. Nowadays, a lot of money is being made on the service industry, not actually the product industry. Think about other means of services nowadays compared to like 10 years ago. What are the other services? And you have to, Lyft obviously, Uber, Lyft, same thing.
Like house cleaning, like manual labor and stuff is really expensive.
House cleaning, manual labor, huge, especially because nowadays a lot of people are buying things on like Groupon and stuff. You see them all over the place on Groupon. You see things like massage therapy, half off your massage. The idea behind a lot of these things is that the concept that once you go once, you want to go again, you want to use that service again. So a lot of services are now giving these crazy promotions in the beginning so that you get hooked or that you start using their service. Seamless and Grubhub, the food industry, used to be the biggest one. It was the only one out there for a while. Now Uber Eats is trying to compete with it. There's another one called E24.
Postmates.
Was it?
Postmates.
Postmates?
Yeah, that's
That's
like another,
right?
like,
Yeah, and that actually, I got something in the mail for $10 off the first order, and I think it was called Postmates, yeah. But they're all doing the same thing now. Amazon Pantry, food delivery services for like produce and stuff. The concept of the design of this actual industry and service has been changing because of the way that the world works now. Especially with like things like overpopulation. Especially when there's more and more people, these services can be offered. Do you think something like Uber Eats would work well in the mountains of Montana? Obviously not. I would hope nobody would ever say yes to that question. Because it's common sense. No one's going to be delivering to you in your remote desolation in your area, and there's not even going to be choices. You probably have the diner 3 miles away and the supermarket 10 miles away, and that's your choice of food. Those people aren't going to be using that stuff. So the design process of that changes based on the actual industry. But again, the important part here is to recognize application and design. Application and design. This was fun. Do me a favor, whoever wants to do it can do this right now. Urban Dictionary, the word engineer.
I have it on my phone. Can I use that?
Go for it. Urban Dictionary, the word engineer. And I mean, hopefully they didn't take that one. But I'm going to pause our recording to make this, politically. I'll take record there. What about modeling? Where's modeling used in engineering? Think about modeling. What would you do with that?
To design your invention before you actually make it.
Exactly. To go through the process of looking at and analyzing the project before you're actually building it, before you actually make it mass produced. Maybe you make one prototype. Maybe you use computational fluid dynamics on a computer and you test something out. You want to build this new heat sink for a computer that can dissipate so much heat, all this stuff. You can test it out with a simulation first. There are programs that engineers use where they design stuff and they could say apply a heat source to this location with this much heat flux, see how the heat dissipates over time, run a real life simulation of it, or you make a physical prototype and use that as a model. And then responsibility, this is what I've been talking about, kind of the whole period about responsibility to the public. Okay, you have a responsibility to mankind to make products that are safe. That is one of the first things you learn as an engineer, and especially when you become a professional engineer. Believe it or not, like you know how doctors take their what's it called? Hippocratic oath?
Yeah.
Hippocratic oath is the right word?
Yes.
Like, what's the, oh, that's not Hippocratic. Hippocratic, right? Yeah, Hippocratic would be the other one. Hippocratic oath is the oath that they take to save humans, to never let a life go to waste, to never be like, have you ever heard this before? That if you put organ donor on your card, it's not a good idea. Has anyone ever told you that?
Yeah.
Somebody told me that once.
Because people are gonna harvest your organs.
Exactly. You gotta believe in the good of people. You can't say I'm not gonna put organ donor because if a doctor, somebody tried to tell me once that if a doctor sees organ donor on your license, mine says organ donor, that if you're close to dying, they might not try to save you because they could use your organs to save 10 other people. Again, that goes against anything that ethical, moral behavior says and what doctors swear to do. Engineers are the same thing. Okay? Again, a person needs to be more unethical in life. Engineers have that responsibility themselves as well. Questions, comments, anything so far? Anything you want to chime in, obviously feel free to just talk. So, 4 branches. These are the main 4. There are many other branches today that stem from these main 4. Give me an example of a branch of engineering today that's not listed here. Aerospace, where would it fall, you think? Mechanical. Mechanical involves things in motion. Civil involves things that are stationary. It's the easiest way to remember. Stationary, motion, traditionally. What else? Genetic. What do you think that would fall? Chemical.
Computing.
Which is electrical. Nowadays they're called ECEs, electrical computer engineers. When you go to college for electrical or computer engineering, you're in the same group for the first 2 years. And then in your 3rd or 4th year of school, you either become a computer or electrical, or maybe a double major. Either one. There are a lot of others, is what I'm saying. But these are the main 4 that started. Let's talk about where they came from. Okay, so chemical engineering. This was really the application of physics, chemistry, bio, in order to come up with some sort of new products as far as medicine were concerned, and polymers. Those are the big things that started. What are polymers? What do I mean by new polymers? How many of you like to exercise at some point, have exercised or played a sport or something? How many of you done something where you sweat before? Please all raise your hand, you all sweat. Okay, so have you ever worn those sweat-wicking shirts? You never worn those before? You should try this. They're actually pretty comfortable because they wick the sweat and they go outside of the surface supposed to cool you off. Why are you able to wear those nowadays? Chemical engineering. It's all chemical engineering, all of them. Material science and materials engineering falls in there, and that's the real branch, but it's all because of chemical engineering. Okay, those polymers, those materials were created. And pick up with this real quick next class. We'll finish this in the first half of the period. Yeah, we will. Civil really came about as a need for public service, actually. So bridges, buildings, infrastructure. I'm going to show you guys a funny video this year on infrastructure. It's absolutely hysterical. What's the HBO show? Last week or last night?
Last week tonight.
Who's the guy? John Oliver. He does a segment. Don't watch it yet, please. We'll watch it as a class. It's so funny. It's on infrastructure, and it's hysterical. And if you know what infrastructure is, it's just like what is built around you, really. It's the structures of everything that you use in everyday life. It's pretty much civil engineering. Mechanical really came about, actually, and we're going to see this when we go to the history, and we'll probably talk about it anyway. Mechanical portion really came out with wars, too. So it had to do a lot with destruction, unfortunately. So mechanical was not always for the greater good of humankind. That's your focus on, right? And I'm going back there just looking at it. Okay. Electrical is really electrical and computer together. I think I mentioned this last class. You really don't have electrical without a computer, or vice versa anymore. Let's see. All right, let's go to history for a little while. So first, origin. As far back as things like the first tools and stuff, you think of people in engineering. But really the whole concept is for engineering design and mechanical advantage. What does mechanical advantage mean?
It's like you take a certain equipment, get out of your output.
Exactly. That's really what it's all about when you think about it. I mean, how could you make a building? How could you move these things without some sort of mechanical advantage? The pyramids were not built without mechanical advantages in some way or another. To this day, they still hypothesize how was it possible for so much mass to be moved without the mechanisms that we have today in the machines. So you have to consider the fact that there were things like pulleys. There were things like there were things like rollers to reduce friction. They use rollers. Ever seen an object go through like an Amazon warehouse down an assembly line? They're rollers. And the box just slides, and they're just rollers, they slide down the whole thing. They used that in the sand. That was part of their thing. But it didn't make sense to them. There's like not enough evidence, they say. But the concept of mechanical advantage of anything. Let's see. It dates back to a long time when it was really about the constructor of military engines. And this was in 1300. I have highlighted stuff that I like to point out. This is much here that I wrote. Again, I talked about being for war. So the earliest civil engineer, his name, and this was again with the pyramids, just to show how far back it was. Ever seen the Mummy?
Yes.
Yeah.
What's the guy's name in the Mummy?
Emotep?
What is it?
Emotep?
Emotep. It's the exact name of this. Isn't that funny? And I swear, like the last 2 years, nobody seems to know that name. Everybody says they see the Mummy. Do you remember the name Emotep? That's this guy's name. So anyway, that's what I remember. But it's just a very random fun fact that I
Was
wrote
it
down.
like King Tut's dad?
He was one of the officials of the pharaoh.
Yeah.
He designed and supervised the construction of many of the pyramids. That's at least what they suppose. I guess it's not really, as I say, written in stone. But no? Someone forgot that? No. We were talking about rollers a minute ago. You could have really spun that well. It would have been a stretch. Let's see. Electrical engineering. The first was William Gilbert. He was known to coin the term electricity, actually. Faraday was a big contributor in the 1800s, and that's why they have like the Faraday cage named after him. It was really experiments in which they were able to ground the system and do an actual electrical experiment that wasn't interrupted by nature. The Faraday cage. Maxwell was a big proponent in electrical engineering in the 19th century. And then some other inventions. There were huge inventions. The transistor was a big thing that changed the computing technology and capability. Probably one of the biggest inventions. They have like, if you're ever interested in computer engineering, if you want to watch videos on the transistor, I have like 10 of them. It really, have you seen? Seriously.
I've definitely seen it. I watched it again.
The invention of the transistor was huge. We'll talk about it this year. All right, chemical engineering. So chemical engineering, this was interesting I was reading about. It came about at the same time as mechanical, and it really came about with it. It was mainly used with industrial engineering, which is a subset of mechanical, obviously, but it was mainly used with industrial engineering, with any sort of fabrication, any sort of pharmaceutical, textiles, materials engineering. So for example, they started building with better materials. They use steel, they use reinforced, carbon fiber now. I mean, they use at one point, we're talking about like concrete with rebar through the concrete. That was a huge advancement, huge. But where does concrete come into play? It's really coming into play with chemical. Concrete, I think if I'm correct, is limestone, mortar, and some sort of water. Anyhow, so the history of these 4 different fields. I'm going to talk about quickly a few different engineers that were famous and known for what they did. A lot of you hear about Tesla, but what he's really known for is AC circuits, so alternating current. So we briefly talked about alternating versus direct current in physics. And if you recall, I showed like a simple graph with the concept of the poles and the polarity switching for alternating currents versus a direct current where you have one positive and one negative terminal. It flows always in one direction. Tesla was big for the AC electrical system. I have no voice, I'm sorry guys. Edison, what was Edison famous for? Obviously not just the light bulb. I know a lot of Christianity. What else? And I don't mean what else as far as other inventions, but what was he actually known for? Some feat. F-E-A-T, feat. Say? Very possible. I don't know that. He was involved with, I don't have Morse code. I have a bunch of things written down, but it's very possible. I mean more general, not specific. Sorry, but that is very possible Morse code. I meant more general. You have more specific?
I was going to say tape recorder.
A tape recorder? He was involved with a lot of things with telegraph, telephone, stock ticker. These things all sound like stock ticker or ticking. You think about Morse code, telephone. It's probably a lot. It's probably yes, because of the feat that he accomplished. Anyone know? He has a,
something electrical? No?
No.
Okay.
I think he has, I'm not sure if it's the most, one of the most numbers of inventions. He has 1,093 inventions. This guy invented like so many things. Everybody knows him for the light bulb, but the actual thing about him was that he was known for so many other things in his lifetime. They called him the Wizard of Menlo Park. No joke. That was his nickname, the Wizard of Menlo Park. Simply because of the fact that he was known for being up all hours of the night, inventing the most ridiculous things. And you have to consider also, like, part of me wishes I was living in an earlier age, or like, I just wish like things weren't all invented already. Because there would have been so much opportunity for things. Whereas now it's like, I don't want to say everything's been discovered, but the laws of physics govern so much now. We know so much more that there's so much less left for us to actually either innovate on or discover. There's actually, with 5 minutes left, remind me, I want to talk about innovation versus invention in different topics. And you guys remember Ev O'Byrne?
Yeah.
Ev sent me an article when she was in the class. She goes, oh, this is really cool for engineering. And she was in my class, she sent it to me, and we used it, we were in class actually. And it's a really interesting article about the difference between innovation and inventions. And again, Edison was known for inventions. Because at that time, you could invent a lot of things. Now, what are you doing? You're not really inventing anymore. What are people doing? Innovating. They're innovating. What's innovation? You just so clear on that.
Isn't it like making something better?
Yeah. Pretty much making something better or cheaper or stronger or easier, but in general, enhancing a product or service. Services specifically. Uber is not an invention, it's an innovation. All they did was take a taxi cab, GPS, and a smartphone, and put them together. Some smart guy that thought of it said, hey, you know what, we can make money off this. Why not do it? There's no market for it. It's an innovation. It's not really an invention. It's been around. It was more just putting those things together, right? All right, anyway, sorry, I went on a bit of a tangent there. So, Reginald Fendison, he was known mainly for wireless communication. So, the first program of speech and music ever transmitted by radio, he was the one who broadcasted in 1906. Why might this be really important? What did that create for us? Wide range radio broadcasting. What did it help? At that time, obviously now there's a lot more too. It's specific 1906.
Radio.
Radio in general, but for what application?
Wartime.
Yeah, for war. Okay, for war. Specifically for defense. Defense. We all know that's a load of. Grace Murray Hopper. Grace Murray Hopper. Anyone? Yeah.
She was a computer science lady. She was in the Navy, and she made a clock that like went backwards. Or
She did several things. Is that one of them? I didn't know that.
No, I know the clock. She was Ages Computer Science at Johns Hopkins. So she goes to the Grace Hopper conference every year, and she got me this stick.
And she made a clock. Is that what
I know it didn't go in the right way. I mean, because she made it because people kept telling her she couldn't do it. So then she did that.
She was one of the most famous female engineers and one of the earliest, in addition. And one of the big things that she was known for, so she did a lot with US Navy, like you're saying, computer engineering. But did you ever hear somebody say the computer got a bug? Computer bug? You ever heard that term?
Yeah.
She coined it. She was working in the U.S. Navy, and they had some problems with their computer system. They couldn't figure out. You know what happened?
Yeah, they couldn't figure it out, and then they opened up the computer and there was a bug, like interfering with one of the connections.
A moth actually was chewing through the lines. A moth. Remember how moths chew through your clothes? They're going to get mothballs. A moth chewed into one of the electrical or one of the lines of the computer, and it caused the problem. And they couldn't figure out the problem forever until they finally took it apart and found the moth. And they said it got a bug, and that's where the term computer bug came from. That was more of a fun fact, whereas I think what Miles said is probably more important, right? Goddard. You've heard of Goddard? Ever heard of the term Goddard? Jimmy Neutron. Ever heard Goddard? Who heard the term Goddard ever?
Yeah.
Say again?
Goddard, with relation to what?
Goddard.
Robots.
I mean, maybe. But
Goddard.
Space exploration. Goddard space
Oh,
station.
yeah.
In DC? DC or Maryland? One of those two.
The Chinese space station that's falling.
No.
So they have their the Tiangong space station. That's like it's kind of like a test. So it's Tiangong 1, and then Tiangong 3 is gonna be the big one. But right now,
People to inhabit?
well, yeah, it's gonna be like it's all leading up to Tiangong 3. But Tiangong 1 is in space in orbit with astronauts and equipment and everything. And by 2017, it will fall out of orbit and come back and like get destroyed and come. Like they miscalculated somehow. Yeah.
Something like curious. Probably Google it. Something like these. I want to read that.
Nice try, man. Very catchy.
Let's try what?
Nice.
What?
Let's try it.
What?
I always and you have to swipe. You can't swipe to no longer.
Oh
I
yeah.
hate it so much. Like
Okay, so in iOS 10, you can't swipe.
You don't swipe to unlock. You have to
Yeah.
press the home button. So.
Oh, I didn't update it, I guess.
That's it.
Oh my god.
Another
Can
Like,
you try it out of it?
No, don't.
don't update. It's cancer.
Thank you. Good to
I actually really like it.
You can play games in iMessage, but like that's the only.
Yeah, that's what I'm saying. But like,
So yeah, Goddard's
the
known.
amount of times I'm like.
Goddard's known mainly for rocket engines. Now, one of the big things was he was used, or he's successful in developing solid rocket fuel. What is solid rocket fuel? Why is that important?
It's like tradition more for us than what it's on. Turn it off.
You get more from it than you would from that good. What else?
It doesn't bounce around.
Doesn't move around.
It's more.
Oh, crap.
Maybe, can you like put it in a smaller space without just
You get more from it.
It's like more durable.
The word durable, not a right word, but yes, you're on a trend. Stable.
Oh, so
Stability.
it's like
No. Chemical stability, like for not exploding. It's not safety wise.
that's it.
He was also used for a lot of military applications now. Because of the study of rockets and NASA, I don't know if you know this, but a lot of what we know today, a lot of like really cool inventions and devices and things you use came back from NASA. People don't know this. And that's one of the big things about they talk about NASA funding, how they want to cut NASA funding and stuff, and it's a waste of money, the space race is over kind of thing. It's definitely not. A lot of the funding that goes into NASA actually comes back to you, if you realize it or not. So you should really be proponents of it. But again, things like the bazooka were created as a result of this, as a result of solid rocket components. All right, Bessemer, from history
Steel.
class, steel. Okay, inexpensive mass production of steel. That's really what he's known for, right? The man of steel.
Ha!
The man of steel.
Blast.
Who was that? Stinson. So she was just the first graduate female engineer, and this was from NC State. What was important about her? Oh, here you go. She founded the Society for Women Engineers. Bless you.
Thank you.
She founded the Society for Women Engineers, which is really important because honestly, for a long time, it was very stereotypical for males to either only be the engineers or to honestly treat female engineers like as if they weren't the same, which makes no sense because nowadays you see some of the most intelligent people, especially in science, are females. So she was one of the first to really be a proponent of engineering for women and founded the society after. This was when she retired in 1973.
My dad said it used to be like that a lot on Wall Street too.
Oh, absolutely, absolutely. I mean, if you weren't a secretary, you didn't like have to replace in the office.
Yeah,
anymore.
yeah.
Yeah. All right. So let's quickly run through these next few things, and I put some pictures of some stuff up. If you know about it and you can figure out or tell me why you think it would be some sort of historical accomplishment, tell me what you think the answer would be. So, who's been to or knows what the aqueduct of Segovia? I've been to. I went last summer actually, the first time. And I was so excited. Spain.
Pablo.
This is not in this class.
Does anybody know why it's important or why aqueducts in general are important?
Does it carry water like long distances?
Using
We have those
Using?
in
Gravity.
crab.
We have those in New York.
You have them where?
There's
The major
aqueducts in New York.
Oh, they're definitely. But I'm saying this is back like in the Roman Empire and stuff. Aqueducts were used to carry water long distances when there weren't pumps.
The Indians, they built the aqueducts.
Did they? I don't think they did actually. Pretty sure this was from Europe, but but I may be wrong in case you were some confusion. I don't know.
Jesus came over.
That's what it was. John, I forgot. Jesus. So you know what's interesting about the aqueduct? I should mention this. I don't know if you know this. It's a 1% grade. 1% grade. That's all it is that causes the water to flow. What does that mean, 1% grade? 1% grade.
Wait, what? What?
The grade. It's a 1% grade is what causes the water to flow. The decline. So every 100 feet this way, how much does it go? Down.
1 grade.
1 foot. That's 1% grade. 2% grade would be every 100 feet, 2 feet. It's the same thing as slope, but a lot of technical terms use grade. So it's a 1% slope that is going down. Meaning every 100 feet, it only drops 1 foot. It's able to carry water onto it. Let's see. What else? So the pyramids, in general, the Pyramid of Giza. Some interesting facts for you. Ready? 2.3 million stone blocks were used. The biggest of them, of these stone blocks, weigh, ready for this? 80 tons. What's a ton? 2,000 pounds. So tap on a zero, it's 20,000 pounds. Well, about 160,000 pounds for one of these. And they moved 2.3 million of them. So you tell me they didn't have some sort of scientific knowledge that was necessary. They definitely, it's nothing.
It's so frustrating.
Let's see. Limestone, granite, mortar. I mean, these numbers don't really matter, but 5.5 million tons of limestone. Insane. 8,000 tons of granite, 500,000 tons of mortar. Yeah. Next, let's go to the Panama Canal. And we're going to pause in a moment and we're going to look at a quick video. If you don't know how a canal works, it's amazing. And there are some really cool canals too that are completely different from this. This is a standard locking canal where the gate opens and closes and the water level changes. And we'll see a video. But there's another canal that most people have never seen that Elliot sent to me in a video a couple years back. It's so cool. Just wait till you see it. So how does the Panama Canal work? How does the Panama Canal work? Nick.
There's locks.
Okay.
So the boat goes in to one lock, the wall is closed, then the water level rises to the next lock, which has the same water level, and it keeps on rising, and then on the other side of the hill, then it lowers the boat to stand on it.
So it does the same thing on the opposite side. Good, Nick. So it enters here at low level. This gate closes right here. A lock goes in place. The gate's literally closed. You'll see in a moment. The water level rises to be level with this. This gate opens. The boat goes out. Why does this happen? There is, let's see. I'm trying to think of the distance, if I have a distance. Doesn't say the distance. It says that it has a 16 foot. It's 16 feet there. No, but some interesting facts about it that I have written down. Let's see. To do this, it took 42,000 workers. Because remember, what was here before they built this canal? What was that?
Land.
Thank you, land. So land was there. Land was there, and they had to move earth and dredge through that land. They moved, ready for this? Enough rubble to bury Manhattan 12 feet deep in rubble. So think about all of Manhattan covered in 12 feet of just actual earth.
Manhattan, what year?
Now, I assume this is written soon. This is written recently. This time.
The
What are the
apartment
buildings?
buildings that were just built, that are really tall.
Imagine there's no apartment buildings. Obviously, I'm saying.
So what do you
that's
measuring it by?
The square footage of Manhattan, 12 feet high, is the volume.
Okay.
That's
If you want volume, you always take the area of the base times the height. So the area of Manhattan times 12 feet would be the volume of earth that was dredged up.
I thought it was like as tall
I
as
know
the
you're
little
sure.
sheds and
Well, you want to hear? It is. If you think about it, ready? It's the amount of earth needed if you dug a 16-foot circular or 16-foot radius tunnel to the center of the earth. That's how much earth was actually excavated for that. 16-foot radius tunnel to the earth.
also in that movie.
What was?
Brandon Fraser.
Brandon Fraser is in that movie and he's in the Mummy movie. Brandon Fraser's just all over that movie.
Brendan Fraser is very funny. He's also in an older movie called, and it also involves science.
The zoologist, no.
Old movie. He gets frozen in time, and then
the
he,
caveman.
yeah, he's like a caveman, like 2,000 years later.
I love that movie.
Do you know what I'm talking about?
Yeah, and then there's an earthquake, and then he goes to he starts going to high school with the guy.
That's Robert Williams and George. Anyhow, let's take a look at a video of the Panama Canal now. That works. I realized I can put a browser in here now and record. I used to have to leave the app and go to YouTube. So this might actually work pretty well.
Crazy, dude.
Thank you, Nick.
You're like, it is.
It's very useful. Because, yeah, look, now the video will be recording as you do.
That's pretty cool. We watched this in USA.
Yeah.
Did you really?
Yeah, the same one.
All right, let me go to the other one then. I'll go to the other type. So you've seen a canal open and close?
That's probably.
How did nobody mention that already?
Elliot saw it.
All right, to go to the other one though, I guess, yeah, I can't do it in the video. I have to pause. So the Great Wall of China we're talking about, or we're going to talk about next. Why might this be a feat? Why might this be considered a feat? Because they made a long wall.
Because it was, and nothing had been made ever like this, and it's also it takes a lot of manpower to create something.
Yeah, it was really what went into it. Yeah, the terrain is the biggest part. Look at the picture. It's in the picture for that reason. It's incredible. One of the, I'm trying to think of some fun facts here. I'm wanting some neat facts. What have you heard any like stories about the Great Wall? Like the workers in the Great Wall? Have you heard these stories? Yeah, there's stories that if workers died, they used them as building material because this took so much building material to go through it. I don't know how true that actually is.
That's true for some of the bridges in New York, because people would fall into
In
the
Brooklyn
cement.
Bridge.
Yeah.
You know where that is actually true? We're going to talk about the Brooklyn Bridge this year, and we're going to have a video on it. It's also true in the foundation of the bridges.
Yeah, that's
Yeah,
what I'm
that's
saying.
Oh, underneath it.
Yeah.
This body.
These are like in the bridge.
No, in the cement.
Underground.
Because people, yeah, because people fell into the cement, they couldn't get them out, so they just kept
Or
pouring.
people that actually died down below when they're doing the work underneath the water.
Yeah.
They definitely had like emergencies. They definitely had like problems down there, and with oxygen they had problems too.
So
There's definitely known to be people.
someone died and
They left them in the foundation of it.
there's no saver, there's no chance of
There's
saving.
no but that's actually a true story. That's in the documentary we watched. Let's see. So one of the big things about it is that there are beacon towers, and they served as defense for soldiers. So this was also for war again. Let's see. Yeah, they just talk about pretty much the fact that They used every and any material to build this wall. That's the really important feat here. They talk about honestly using like parts of food. They talk about using, let's see, like woven mats tied together on parts of the wall and then reinforced. So this was not more of an accomplishment for its structural integrity, but more of the fact that it actually got built. Hoover Dam. Why is a dam very important? What does it do? What does a dam do? I don't use the word block, but use another word. Creates electricity. It might filter. They probably do have filtration systems, but not for filtering, really. Blocking is an okay word, but it's not the right word. A dam does what, really? Because water does go through.
It keeps the water level at a certain height for like civilizations that are down
Exactly. It controls the flow. A dam controls the flow. Yes, Nick, it generates electricity, which is huge. It's huge. And it does block it up, but it does control it. Water goes through. So the idea here is that it controls the flow and the civilization down from the actual body of water is able to survive and not get flooded. But there have been catastrophes for dams. Yes, you might say, damn. What about the Hoover Dam is really important? Let's see. So it flows at 20,000 gallons per second, which is a decent size. That's about 15 swimming pools, 20,000 gallons. Every second, that much water is flowing through. All right. Let's talk about the next idea. This is called the Channel Tunnel. How many of you have heard of this before, or seen, or heard the name ever? You know where it is?
It's like between the UK and France. I was
Yeah.
watching a video and saw that. He's like, I'm going to France and it just stopped.
So it's this underwater tunnel that connects two countries that hadn't been connected this way. What's interesting about it too is that the setup of the system itself was new. They never had this. In addition to it, the concept of pressure. So it has to maintain pressure because of the high speeds that is occurring. And obviously we know with subways we have that also. If you've ever gone underground, what do you feel when you're underground? What do you feel when you're underground? Maybe heat, but what do you, true, we always feel heat in our subway. But what do you feel in your body when you go underground at high speeds?
Here's popping pressure changes.
Pressure changes. Pressure
Oh,
changes.
you're kind of like really far now, but like the subway.
At high enough speeds, if you're underwater, you will, for sure.
But
Your
that's
ears
about
never
the
filled?
speed.
Your ears never filled before?
Not
Like
like
an elevator.
train, like when I'm going up like on a mountain or something like that.
Or in a
But
plane.
underground, the pressure differential is so high that you can easily feel it. You've never, even on like the Long Island Railroad, the Metro North, no?
I don't think.
When you go from Jamaica to the city, you go underground for a good amount of time to Penn Station. You've never had your ears filled?
Nope.
You've never had a sinus cold on a train and you had like that pain ever?
You just have weird ears.
I feel like it's not just me. I'm like, you guys are all looking like I'm crazy right now.
Crazy.
That was one of the big issues they had with this because they were high speed. Let's see what else.
You're a crazy
The speeds are up to 100 miles an hour. The crazy part, how do they board these? Anyone know? How do they get on?
They actually suck them in.
They don't walk on, they drive on.
What?
Yeah, this carries vehicles. So it carries buses and cars. So, I mean, think about the amount of energy necessary to do it. Well, I mean, if you want to commute from one location to another, and you don't mind spending a good amount of money, I'm sure it's a ton of money to do this.
Just like tying down the cars though.
They must lock into place. They must lock onto the axles. It makes sense. If they carry cars, it's probably adjustable axle holders. They move up and they clamp on. Let's see.
I used to think that, like going under the Holland Tunnel, the Lincoln Tunnel, that if the walls cracked, it'd start like the water would rush in. But it's under the water, underground.
It's underground, which is like this much ground, and then there's water after.
Yeah, like when I was little, I was
So-
like, how on
Because
earth
the movie
did they
Daylight,
think so?
the movie Daylight with Sylvester Stallone ruined it for every kid. They thought that like the river was literally, or the tunnel was through the river after that movie. It's not. Oh, it's always underneath the ground.
AM, son, where'd you find those?
Daylight, Sylvester Stallone. There's like a crack in the tunnel, and the water from the river starts spilling in, people are getting drowned alive, and he has to save them. Terrible, terrible acting movie. The physics behind it is so bad.
Also in the color.
It is. It like it fills up, and like the rate at which it's filling up doesn't make sense. It doesn't. If it was true, they'd be like,
Like,
dead.
Because Manhattan has gone into the Hudson River so much over the years because of like the management of everything. The Hudson River has the currents have like picked up, so it's becoming deeper. And
It's carving out more ground.
Yeah, so they're saying that there's a risk of the tunnel breaking or something.
Interesting.
Also, it's impossible to build a tunnel underwater. Like, how do you do that?
So it's sort of like-
How do they do it underground, right?
No, but like, how do they do it underwater? Like,
So you
do they make air pockets? Like, I don't know.
No.
They have to have a structure that extends continuously
No,
that
they
builds
make
into
the
it.
tunnel and then take the water out.
yeah.
That's a lot of hard work. That'd be harder than just drilling.
They may also build the tunnel in pieces and lower it into the
Yeah.
actual water too.
And that's not down the water.
Yeah, just
Or just vacuum seal it when they attach it over the gaskets. Yeah, there's I'm sure there's many ways. I don't know. That'd be, it'd be cool to see that. I was like,
I'm not saying it's
not how it's made, but like one of those kind of shows.
how it's made.
I'm gonna skip this. I don't really care about this. I don't really care about it though. I don't know why I put it. It's an accomplishment because of it wasn't there. It's completely man-made. That's why it's an accomplishment.
You see they're gonna make like a man-made part of New York on the bottom? In the south end?
Yeah?
Yeah,
They're gonna extend. They're gonna extend Manhattan.
Yeah.
That's cool. What's the project date supposed to be? So this bridge was in Japan. It took 2 million workers 10 years to construct. Yeah, I don't even know how to say it. Let's see. So the reason this was built, first of all, it's the longest suspension bridge in the world. It covers 1,991 meters, which is over a mile. 1,600 meters is a mile. So this bridge is over a mile in distance. The reason it was built was because of the fact that prior to this, tons of people kept dying, actually. They would take ferries between these islands. There's 2 islands they couldn't connect. And in 1955 alone, 168 people died on the ferry. In different instances because the water was so severe with storms and stuff. So that they built this bridge high enough so that you didn't worry anymore. Yeah. The last but not least accomplishment is the Grand Canyon, the skywalk itself. The only they do. It's a straight bridge and it's glass. You can look through.
That's
I
terrible.
saw on Facebook someone like took a sledgehammer and it was like or the government or someone tried to like break it, they couldn't break it.
Mm-hmm. It's like this unbreakable glass that's probably super reinforced with some NASA material that they haven't used yet. I was actually talking today with Mr. Donachek about it. We were talking about the new materials that have come out in the last few years that are so much stronger. So for example, things like carbon nanotubes.
Like a spray thing, the black
You've
spray.
seen it? Don't tell any juniors about it. It's going to replace the egg drop project. The other day,
They
they
made
did
a
it
boat.
on an egg. It worked on an
They
egg.
made it out of they made a boat out of it and the screen board.
Oh,
It's the spray.
Yeah,
You remember the spray you can drop from like a certain height?
Like they show commercials of that on TV. Yeah.
You spray it with this black spray, and then you can drop from like 100 feet and it doesn't break.
Oh,
It's
Mr.
incredible.
By the way, I saw a video on the internet that people use the oud-like stuff to stop the egg from breaking, and you told me that wasn't going to work.
No. I've never said that. I told you that in our project, you couldn't put that stuff at the bottom. That was the proposal for it to be at the bottom to catch it.
I never
Never
said
said it was going to work.
there was nothing at the bottom. What?
Real quick, you're talking about the
Yeah, I was going to put it in a container and drop it. and do something.
This is really cool because it's structural integrity. It can hold a lot more weight than you would ever imagine. I did put a reading assignment up for next class. Okay? Take a look. I'm definitely going to give you another quiz. Major reading sound in the next class. So make sure you do it.
When you do that?
Time to die.
Nick, I always had was this. Inside of your, what's your veins or arteries? I forget what the professor said. But inside of your body, inside of wherever your blood flows, I don't know if it's the veins or the arteries, which one. You have these little hairs on the inside of the walls. They're not really hairs, but they look like hairs. They look like, they look like little cantilever beams coming off the actual inner wall. So imagine the wall of your vein, the inside of it, there's these little things coming off the wall. They're not made to stop the flow, they're made to regulate the flow, actually. So based on how much they bend, your heart and your body knows how fast your pulse is moving, so you can actually regulate yourself. So when people say like calm down and relax, it's not always you can't always do it yourself. But your body itself has these little sensors, in a sense, inside of them that can tell how fast the blood is flowing and pumping and how much pressure it's putting, and knowing to regulate the body to slow down. These are one of the many feedback mechanisms in your body that regulate your body. Think about it. How does your body stay in homeostasis? Homeostasis. How is that possible? I don't know. It's a terrible word. Physically, it's all the feedback mechanisms in your body. It really is. Your neurons and your neurological system. Is that where you feel pain? Is that right?
Yeah.
I forget my body. That system is a feedback system. Whether you realize it or not. What happens when you touch a hot iron? You move your hand, don't you? It's a feedback system. It's a sensory perception that sends that signal at the speed of light to your brain that says, move that hand right away. And you pull your hand off. That's why when people hear those crazy stories of people on drugs and stuff, that you've never heard that in your drug education programs.
We don't have them.
When I was a kid, it wasn't at school. You could do it on the side. It wasn't at school. We used to take a DARE class after school.
We
Remember
had
DARE?
that in the
Yeah.
Drug abuse resistance education.
They stop.
Do you remember stories that we tell?
Dare the lion.
There's the stories of the guy who thought he was an orange and peeled his own skin off. Oh yeah, on different crazy drugs. Ridiculous things. Things like heroin, things like acid, and things that are really mess up your mind.
Those guys that chop off their fingers.
Oh yeah, and don't feel pain at all. They don't even feel anything happening. That's the same story about people that put their hand on a hot burner and don't realize they're burning their hand because the drugs that they're on prevent the body from actually feeling it. So what's the lesson for today? Don't do drugs.
No, then you don't feel pain.
It's not that kind of a good thing though, Nick. And be careful with that, because a lot of people get hooked on that kind of stuff. All right, so let's now transition after accomplishments into disasters, because clearly there have been many engineering disasters, many. And whether we realize it or acknowledge all of them is one instance, but we're going to look at some of them.
Isn't there a Canadian Engineering Society that you're a part of? Because
But I'm part of it?
no, engineers are a part of because after they graduate, because one time in Canada they tried to make a bridge and then it collapsed, and then they made a bridge again and that also collapsed. So then they decided that you might as well just work together and stuff.
Well, the U.S. has ASME and ASCE, American Society of Mechanical Engineers, American Society of Civil
Aegis
Engineers.
boyfriend is a part of that.
I don't know. I'm not sure if they work together or they merge. No, I'm not sure. But this example is in the U.S., not Canada. So, anybody know what's going on at Arrows Bridge?
It's just the one
Have
that.
you seen the video? Go over it.
I've seen that picture.
It's not that. Oh, actually, it is that one. Yeah, it is.
That exact picture.
It is exactly that picture. I'm going to show a quick video about it. Let's see. What's that? I can't hear. You could put I found this out recently, actually, so I'm kind of excited about that.
Oh yeah, I saw that when I was making when I was looking at 6 or everything. I thought you were gonna do that.
You saw what?
Like when in physics, when I had to make the videos and I started using it for
Yeah, that you can insert a browser?
Yeah, I knew that.
So cool.
I didn't know you knew that.
Yeah, I didn't really realize it. All right, so let's go to.
Sound version.
I don't know if it. All right, let's see how loud it's going to be.
Oh, who has to collapse?
We're going to get. It's only 2 minutes long. It'll show the claps. Oh, it's music. It's not like the real sound.
And against the speak with a roar that no man can fail to hear.
So, what happened is the wind itself caused the bridge to reach what's natural frequency, which allows objects to start to vibrate or oscillate, but they oscillate out of control. The oscillations are not able to minimize. So the oscillations continue and continue. There's a dog somewhere here, I think. So there's a dog died. There's a dog died. Don't ruin anything, Nick. Seriously. I'm gonna full screen it actually. There we go. It's a little bit bigger. He was just walking away. Love that. Out west somewhere. I don't know. It's Coleman Arrows. I don't know what that is. Oh, there's the dog. Yeah. Nick, there's the dog. Is that a person?
No, I think
That's a car.
That's a car, but before, was that a dog?
Trying to get their dog. Rip the dog.
But he saved himself by a second.
Why is this?
Just like catch
He's taking his time.
No structure of steel and concrete can stand such a flame. Steel girders follow, and giant cables snap like 2D threads. There it goes!
So to this day, I always wonder if this is a recreation of it somehow, or if this is the actual. I think it's the actual thing.
This is actually.
I'd assume it's the actual thing, right? But who happened to have a video camera on the bridge that day?
Well, maybe it was like happening for a while. They're like, get the newspapers out.
Maybe, yeah.
For whatever reason, the Como will rebuild. This time on bridge.
All right, that's it. So we have to talk about that. But yeah,
I think I know what the problem with the bridge was. It wasn't it they didn't build it with like the triangles. That's what I always learned in middle school.
they didn't use a truss structure. Well, first of all, I understand what you're saying. That could have helped reinforce it for sure. Yeah, if they had used a truss support underneath it, it could have helped. This was suspension bridge. That's why they used the triangles. You think the truss structure. So bridges, when we get to bridges, we're going to talk a lot about bridges here actually. And the different structures change the way the bridge behaves. So a bridge like this, that's a suspension bridge, because it started to like fluctuate a lot, was able to stretch, those cables started swinging similar, yeah, that's what you see in the back of the room, that's a good point. It starts to move. But here, or at least when I researched this in engineering when I was in school, the idea was that the bridge itself reached a vibration that was uncontrolled by the bridge. And it had to do with the weather that day, the wind, all this stuff that came into play. I had one other piece of tidbit I wrote down, I think, let's see, where is it? They replaced the bridge in 1950, 10 years later. Let's see. And then eventually they actually made a whole different model, a new bridge next to it, one that was parallel next to it in 2007, because the other bridge itself is not that good.
Oh, they're doing it to Tennessee.
Is that what they're doing right now? They're putting a separate bridge?
They're building a whole new thing right next to it.
Yeah, what do I drive over the Kaskaskia Bridge in Brooklyn a lot. It's like this small bridge that's always backed up getting into Brooklyn, and they're doing the exact same thing, which is kind of cool actually. The other day, I was driving, so I couldn't take pictures, as I would have. I was thinking about you guys. No, I really was. They're in the middle of building a bridge, and they're like halfway done with the bridge, and it's a suspension bridge. So it's kind of crazy to think about. How are you halfway done with suspension? Because like to me, they only had like half the cables, yet it was more than supported. So like you talk about factor, we're talking about factor of safety in this class a lot. Only half the cables were up, and the bridge was fine, like more than fine to stand. And they were still putting the other cables up. So you wonder like how much strength can the bridge actually hold? Probably a lot more weight than it actually claims. And that's what factor of safety is. Have you ever got an elevator before? What does it say usually on there? How many pounds does an elevator hold? 2,000 usually, right? 10 people. No offense, but you could easily get 10 people on an elevator usually. Most elevator sizes, right? You get 10 people on there if you squeeze in. An elevator can hold more, because I don't want people to think because they're more than 20. Whatever. So, no, because if you think about an average human being what, 180 pounds? Is that reasonable? 180? Male, female, I don't know, it depends on the sex, but if you have 10 people in there, you could easily reach that limit. So what I'm saying is that limit is actually a number that's not necessarily true. It's called the factor of safety that they incorporate. So maybe the actual elevator can hold 10,000 pounds. The factor of safety is 5. They do that on purpose, so that obviously what happens or what doesn't happen.
Like, great.
Yeah. If it said 2,000 pounds is the limit,
And
you know,
then
human beings, we always want to test the limit kind of thing, you know? So like, if we had 2,100 pounds in there and the thing broke, technically they're not at fault because it said cannot hold more than 2,000 pounds. And usually there's a sensor on the elevator that starts to go bing, 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 and it won't even actually close the doors. Have you ever moved furniture on your own? Ah, people. Well, maybe, yeah, you guys are all young, that's true. Maybe help your parents. I moved furniture on the elevator one time. It wouldn't work because it exceeded the limit of the weight the elevator could hold. It was so frustrating. You brought like 2 things on the elevator, the thing would start beeping like ridiculously. You wouldn't be able to move up and down because it claimed like 1,000 pounds or something like that, and they were couches.
One time I helped a friend move, and this apartment building had this really small elevator that like I didn't even want to go in, so it would shake back and forth while going up.
There's a lot of old elevators in the city like that.
There's
A lot.
The furniture.
The one here in this building is like old as anything, or here outside. It's very old. I go to another doctor over here that I've been going to, and their elevator, literally, between the first and second floor takes like 30 seconds per floor. I have to go to the 5th floor when I go there. I'm like, and everyone always stops. So I'm only elevator in the building, so it's always stopping on every single floor. So that's a scary one because we're packed with like 8 people in there. It's an old elevator. It moves this fast the whole way. You're like,
I have 31 floors in the building, so it's faster.
yeah, I mean, depending on the size, the new elevators are amazing. Have you seen like, so I forget what the building is called, but by Times Square there's this building that has like pods, but not really elevators. I mean, they are elevators, but like chutes more than anything. So you press the floor you want to go to, and it tells you which elevator to go to based on the floor. And there's like, no, that's an exaggeration. 20, this is 60. 20 elevators in like a circle. You enter one area, you press the floor you want to go to, and it says wait for elevator, and it'll say go to elevator 7. And you go to elevator 7 because that's the one that's nearest, or that's the one that will go to that floor next because maybe somebody else is going there. So it optimizes the algorithm so that it spaces it out evenly. But they're like pods, you like shoot up in this like tube. It's kind of cool. It's like a new looking
They have
elevator.
that, they have, well, two things, they have like pods like that at the hospital, like, you know, in the bank, and you put your money in the thing, and it shoots up and goes to the other side.
Yeah, of course.
They have that, like, in between the floors in the hospital, so you can, like, put, like, blood samples and things
And
like that.
shoot up to that's genius. It's a pressurized system that just pops it through.
Yeah, it goes really fast.
Are you gonna take a field trip to a fridge?
That'd be cool.
Yeah.
George Washington.
Well, you have a second thing, right?
Oh, yeah, I was gonna say, one of my family friends, the house that we stayed in, sure, they had an elevator, and like, you put like 3 people in it, and it would just like, it would kinda like sink a little bit when you stepped on it, like even like one person, and we're just like, maybe we should like,
we'll take the stairs.
we just put like the suitcases in there and like sent them up to the 3rd floor.
I mean, I'm always scared about old elevators, especially after I've seen those movies where like you're like, if an elevator breaks, you're not making it. Sorry, it's not happening. Unless you're on like the 1st floor and it moves, maybe it drops 10 feet, but you're still gonna get injured then. But you see these movies where people survive elevator crashes, which is ridiculous.
Maybe you just
No
like
offense,
hang
but
on.
you're not
to the
gonna.
top.
Yeah, maybe I get messed up.
You're gonna get broken.
I mean, the ground's gonna completely crush up into your body like an accordion. Think about the front end of a car when you get into an accident. That's what happens in the bottom of the elevator. You're saying grab the ceiling, pull yourself up so the bottom doesn't hurt you. I have a feeling it's gonna crush so much that unless you can like lay flat and like hook your feet into the ceiling and hold like this,
Or you could like a James Bond thing and like jump out the top and just ride the elevator.
and just hold on to the cable as it's coming down.
Yeah.
Yeah, so your hands tear off and real life.
No, and then
Nah,
just use your belt and like.
Oh yeah, just hook your belt on and pull yourself up, right? As you go
Yeah.
like that last time.
Just jump onto the cable that's going up.
That's what I mean. Yeah, hook onto that, you go straight up through the ceiling. This guy.
Grab up the helicopter.
All right, let's see. All right, so let's go to the next thing. This was just an example of a bridge failure that they obviously did learn from. The second one is Chernobyl. Okay, do you know some history on Chernobyl? History? LT?
Was it a nuclear power plant or something?
Yep. It was a nuclear power plant. Anybody know what happened?
The coolant thing.
It didn't explode.
Meltdown.
Like a coolant system failed.
Yeah, pretty much the sensors, the coolant system failed. They didn't sense that it was overheating. there were mistakes in there, and as a result, when the system should have shut down as an automatic feedback because it reached a certain critical level, it didn't. That's why it's called a meltdown. That was the term meltdown. What else? I'm trying to think of some of the specific things. Eventually, what happened was the reactor itself, the seam on the side ruptured. There were a ton of steam. What is steam explosions? Why are there why would there be steam explosions? What do you know about steam? Pressure. When you have steam, it's got to be at a very, very high pressure. What else? It says that the reactor's graphite moderator was then exposed to air, and that caused the ignition. This is what caused the actual explosion itself. What was the big problem with it? Obviously, well, not big problems. A lot of obvious big problems. What was a long-term problem? Long-term.
Radiation.
Yeah, radiation poisoning in the area. Okay, that's the biggest problem, obviously. Which is why, obviously, you guys know that when they do any sort of nuclear testing, where do they usually do it?
In the ocean.
Either somewhere out in the middle of nowhere or somewhere where like you're in a body of water. So they'll do it like a lot of the time either in the desert where there's nothing else around, or somewhere where they have a reactor that's on the water. Anything else specific? LT?
There's a restaurant by me, and the hottest buffalo wing flavor is called Chernobyl.
Oh, that would make sense. Yes.
I saw this documentary about, I think it was time, or like something on Discovery or something like that, or History Channel. And it was like the wildlife in Chernobyl was like starting to come back, and like Chernobyl has one of the greatest wolf populations or some animal population, like compared to the rest of the world.
Are they?
They're fine.
They're fine.
Yeah.
They're not like mutated at all. Interesting.
Except like, I think they found like one.
With like an extra leg or an extra
No,
foot.
not crazy, just like like a rat coming with like a small level or something. I don't even remember. Maybe.
I wonder if that, well, I mean, obviously it cleared out the population at the time, but I wonder if that actually ended up preserving some of the population there because people did not inhabit that area for a long time now.
Two heads.
It's a cow with two heads. There's a lot of that if you go online and search those pictures. All right, so this was in East Ohio. Now, one of the big things about this, well, one of the first big things here, was that it killed over 130 people. Anytime there's a gas explosion, that's why, by the way, if you ever go to your house or you go home, this happened to me once. I went home, I got to my house in Brooklyn, and I walk in and I smell this like sweet smell, and like, you ever smelled gas before? It's kind of, it is kind of sweet, it's weird, I know. When you see the smell of gas, as soon as I walked in, I smelled it. And I walk in and I find whoever, I don't know if it was my brother, my cousin, or I don't know, a bunch of people. Whoever in the house that day decided to turn the burner on the stove, and when they turned it off, they didn't turn it all the way off. They put it on like just, I guess, live as possible. And it literally was just leaking gas in the house all day long. One simple addition in your gas.
Let it match.
That's a really good idea. So I made sure not to let it match. And then when I opened all the windows, the back and front, until it actually cleared out, I made sure that nobody used the gas at all for like 6-7 hours because I was nervous about it. The whole house stunk like gas. Yeah. Let's see what else. Let's see. Yeah. Oh jeez. Yeah, what is that? Is that a dog?
That's my baby.
Oh, that's freaky.
Anthony, this is for you.
So here was a fun fact. This is not really fun, but it's a fact, I guess. And I thought this was interesting because it's related to physics. So when this happened, as the actual air mixed with what was like the gas in the sewers, it ignited. And as a result, not only was there a huge explosion, but they had, you know what a manhole cover is?
Yeah.
You know how much they weigh? Ridiculous amounts, like 60 to 70 pounds.
Popping up.
That's what happened. These things were launched like 3 miles in the air. Sorry, imagine 80-pound manhole cover coming through your window out of nowhere. It's landed like miles away from the actual site. It's crazy.
Oh
Wait, you mean latitude? Like they went
Yeah.
up
Or down.
or
Horizontally. Well, I guess not. It said 3 miles. It might have been
so like
distance.
the,
Vertically or horizontally?
Probably the distance of the arc, the length of the arc.
But they don't know.
Horizontally would be a bit much.
I don't know, I was like this way and like
What else? Let's see, is there anything else important? Now, let's go to the next thing. All right, so this was, okay. This was a big deal because there was a major engineer that was in charge of this. This guy's name was William Mulholland. He was actually one of the main people to be on the election, on the crew to inspect. But the problem here was that there was a bit of a conflict of interest here, because he was also involved in actually creating the dam itself, but that was one of the main inspectors. Again, this was in 1928, so we're talking a long time ago before huge regulations were in place. So what happened was this dam itself was open. Let's see, when did it fail? It doesn't say when, but when it failed, ready for this? A 10-story wall of water. 10 stories. So imagine we're on the 3rd floor right now, 4th floor. Go double this building high. That's how tall the wave of water, which is pretty much a tsunami at this point. Flowed into the Santa Clarita Valley in LA. Let's see. They were moving, ready the water was moving at 18 miles per hour. 18 miles per hour, 10 stories high. You're done. You're not getting saved from this.
You could drive. You could drive.
Yeah, you can just ride.
You just swim into it.
Sure. So the
No, but
sound.
like you could drive a car faster than the wave of
Oh,
water.
sure. If you could drive away from it, yeah.
Yeah.
He said ride it. You mean like ride it like a surfboard?
Yeah, just get a surfboard.
Get a boogie board.
It was ready for this. Afterward, the town nearby was covered in 20 feet of mud and debris that it carried with it. So even if you did somehow not get killed by the water, you were buried alive under mud and debris. In the Ventura Valley, it was 70 feet deep of mud, different parts. It took, ready for this? It took weeks to clear it out. But the final death toll was 450 people, 40 of which were school children that got stuck in school this time. So this was a huge catastrophe. This was in the 30s, when the dams were not as good as they should be. Seriously, when the dams themselves had not enough regulation for them. All right. The next one you're all familiar with, or you at least all heard of. I feel like everybody in this planet has heard of now, right? We didn't talk about some physics.
Isn't this yeah.
We talking about Challenger in physics?
The video.
Speaking of atomic sky in physics, we talked about that.
Didn't we talk about it when we did after or something?
Possibly. I may have talked about
The video.
it. I didn't specifically go into this topic, but I may have covered it.
The video with the parents' point of view. The parents they're showing the reaction of the parents while it's happening.
Of
It's
the Challenger.
messed up.
I
Yeah.
don't even want to know. I don't even want to know. Of the astronauts, you're saying?
Yeah, like the parents of one of the astronauts.
Well, weren't there also teachers on board? Is this the one?
No, it was the parents of the teacher.
Okay. So, first of all, let's go over this. The reason I want to go over this, there's a lot of detail about this, and there's a lot of problems with this. So explain. Anybody know why the Challenger actually exploded? I'll let you go to the back, but I'll wait till the second period once you start your project. So you time to go.
I'm pretty sure the person who supplied the boosters for the rocket knew that. Oh, actually, it was the person who supplied the boosters knew that there was something wrong with them, and then they were like invested in the Challenger program, and they like left. They sold all their I don't know if it was stocks or something. They sold all their stocks in their investment right before the Challenger launched, so they wouldn't lose all their money when they. I think there was people who knew it was going to.
I honestly don't know that. That might be like.
I read an
That's
article.
probably true. There might be like conspiracy theories against that too.
Well, I don't think it's theory. I mean, I think there's evidence in it. I'll look it up.
I'm just curious because I meant like physically and how it actually failed.
Oh, sorry.
That's alright. That probably could be true, but how it actually failed. I don't know how it actually failed. So what happened is this.
The gas.
It had to do with that, but it had to do with what are called the O-rings. So
Yeah.
on the actual machine, I'm just trying to turn this on. On the actual machine itself, switch is the one that work.
I don't know this.
Does that not work? The what are called O-rings were like these like imagine a washer, okay? A washer that was holding together a certain location that kept the solid liquid or the solid rocket fuel in place. it was tested under certain conditions. Now, it was tested under certain temperatures, certain situations, and standards. On the day of the launch, the morning of, a lot of NASA engineers all said, cancel the launch, cancel the launch. And there's actually record of this. They said it shouldn't have been done, it should never happen. But because there was so much publicity for it, and it was a big deal, the bigger ups, I guess, in like the government, because NASA is funded by the government, the higher ups in the government, said, we don't want to ruin this, we don't want to not have the launch, it should happen anyway. They said it should still work. It took off, the O-rings themselves became brittle because it was too cold that day. They actually cracked and broke, and the actual, was it solid rocket fuel? Well, okay, the solid rocket booster came loose, and it came into contact with the actual booster itself. And then, as a result of that, yeah, the gas was escaping from the actual booster and came into contact with the actual flame, and then the explosion itself continued throughout the entire chamber. I mean, that's not what it actually looked like initially. The actual failure of it was one small part, and it fell on the side, but then it continued to explode throughout. The concept, or the main point I'm trying to point out here is this. The actual NASA engineers that day said this was not a good idea, based on the conditions this was tested under. This is not a good assumption that this is going to work successfully. They were ignored completely. As a result, unfortunately, this happened. This was in 1986, which I put out in 1986. Yeah.
Can we watch a video on this?
Oh, Challenger?
Yeah.
If there is one, I don't know if there is one. This is a picture. Is there actually?
That's a video, yeah.
Yeah, that has to be the video.
I mean, they wouldn't not film it.
I mean, it was the.
I mean, based on how much it costs,
Yeah.
preventing it from not.
It's a disaster. It says graphic. Big graphic.
I'm going with the shorter one. Sorry.
Minus 21 seconds, and the solid rocket booster engine gimbal is now underway. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle.
So you see the actual ship itself and the booster is attached. This is the actual body. I don't know how you can see condensation forming, but apparently you should watch for that.
Oh, I don't think it like the size.
Oh, okay.
So the 25th Space Shuttle mission is now on the way after more delays than NASA cares to count. This morning it looked as though they were not going to be able to get all.
15 seconds, 130, 29 feet per second, altitude 9 nautical miles, generation.
It's terrible, right? I'm not even saying nothing to say.
Looks like a couple of the solid rocket boosters blew away from the side of the shuttle in an explosion.
Did you hear him talking? They weren't sure if they were going to launch it this morning. Did you hear him saying that as it happened? Crazy. That's absolutely crazy. But anyhow, the concept here was that we learned that obviously ethics, morals, human lives are worth more than just some publicity part, right? All right, take a look at the second to last one. So this is a one of those like blips. What's the one you guys all learned about? Hindenburg, right? Hindenburg, is that the one you learned about?
Yeah.
You don't learn about that? I feel like that's
I was
the
gonna say this tire
We just
company,
know it.
Goodyear, that's got the Goodyear plans.
Do you know how the Hindenburg? What happened to Hindenburg?
It's like
It's
they coated the outside with plus the helium.
It's helium gas that was inside, but yeah, it caused an explosion.
Well, now we use hydrogen, right?
To be honest, I don't even know if it's actually one gas. I think it's actually a combination of gases.
Helium is very flammable, so that's. They're like saying it could have been like a spark, maybe like two metal parts, or somebody lit a match, and there was a leak or something.
Well, hydrogen is more flammable than helium, I'm pretty
Yeah,
sure.
it's
Actually.
helium and normal.
Helium is what you put in balloons.
They use hydrogen on the show.
Oh, so they use hydrogen.
hydrogen.
Yeah, the reason it exploded
Correct,
was because it was
but-
hydrogen, now it's helium.
Okay.
Yeah, the original blimp was hydrogen, the one that
Yeah.
exploded the Hindenburg.
Yeah.
That's less stable than helium is. Helium is
Yeah.
like your
Helium's
balloons you get for all that
normal.
stuff. But that is also unstable, helium itself. It's have you ever lit
No, I haven't.
We should.
you ever get like a balloon at like a baby's birthday party or like a regular balloon you go to the store to fill up? Not one that you would blow up yourself, I'm saying? I know, I'm just thinking of babies now. So, my niece, it was her birthday recently. Think of the balloon she had. It was an elbow balloon and it like popped. So all the, helium comes out.
Yeah.
If you ever light it on fire, it'll actually, you'll see it. Well, do you remember last year? Who came to the physics show last year? Did he use, it was hydrogen last year. Was it hydrogen that he used?
Oh,
So I
actually,
said for that one.
No, during the bicycle wheels, it was so long. I'm sorry.
The part of the balloon, the hydrogen balloon that he lit on
Yeah,
fire and
yeah,
you literally saw it
oh,
explode?
I actually something. Oh my
That
gosh.
was hydrogen.
I wore the glasses the whole time, and he didn't even say it.
I know, not till the very end you do that. So this one what happened was, let's see, it was near Paris. It was flying very low speed. Let's see. So unfortunately, it caught the side of a hill, which is kind of crazy. It needed to stop to get more fuel. It caught the side of a hill, and it started leaking hydrogen, and then like almost immediately fire engulfed it. Let's see what happened here. 46 out of the 54 people ended up dead, and then 2 more later on impact, and then 2 more that were brought to the hospital ended up dying. But somehow 6 people survived. That's the one that was kind of weird. But apparently there were more deaths to this than there were with the Hindenburg, which is the one that's always talked about. The Hindenburg was just earlier in time. What are you saying?
I'm gonna send you a link. It's a-
2?
It's a propane balloon, and they have and they light it on fire. It's pretty cool.
The balloon itself, all right. I'll look at that. Let's look at the last thing of this, and then we're done with this topic. So this one I put last because honestly, it's kind of funny actually, even though it's terrible to say. It's called this is the Boston molasses disaster. And it's not a joke at all. I mean, it really did happen. So this was, let's see, I don't know if I put the date on here. No, but it was in Boston, obviously. So what happened was they had these giant molasses tanks that were 50 feet tall and 90 feet in diameter. They would hold like 2.3 million gallons of molasses. Unfortunately, what happened was they started hearing like a rumbling, and then suddenly it sounded like machine guns. And what happened was this. Imagine the drum or the container of molasses is like this. Have you ever looked at a soda can? There's actually a seam in every soda can. There's a seam that runs up and down the side that has to get pressed together almost. And I'll actually, when we talk about the design process, we look at the design process of the can. It's a whole video. It's kind of cool. It's really cool actually. But imagine you have like a piece of paper, and you take a piece of paper, and you do this with it. You take the paper and you roll it up like this. Like you guys are doing with the newspaper, you get a cylinder. So these things are fixed at the seam. This is called the seam right here. So they put rivets in the seam. And a rivet is similar to a bolt, but it's permanently fixed. A bolt, you put one end, you put the bolt through, and you tighten the nut. That's how a bolt nut works. A rivet, it goes through and then it permanently fixes. It depends on the head of the rivet, but it usually comes back, and both ends of the rivet are fixed on it. You'll see this like airplane wings a lot. So what happened was they started to split at the seam. And all these rivets that are located up and down the seam here all started shooting out, literally like bullets out of a machine gun. That's what people started to hear. And then suddenly a few of them collapsed, causing others to start falling down, and it was more of a domino effect. There were 15-foot waves of molasses at 35 miles an hour traveling toward people. There was even an elevated train at the time nearby, and it was so high, there was so much molasses that it got up to the level of the train and lifted the train off of its tracks because of buoyancy. Let's see. Buildings nearby were all completely swept off their foundations, crushed completely. None of them survived. And people-wise, this is the interesting part, though. Only 20 people died.
That's still a lot.
Yeah, but for a disaster this epic or this big of scale, you think there'd be more death. I mean, I don't know. Maybe there was not a lot of people near that day, or they had enough warning.
I sent you an email on this crazy aircraft thing. We watched it. It's 1 or 2 minutes.
Quickly, you guys.